So, Vasha, can you summarize what we have discussed in our last session?
So actually, we did some of the theoretical part of Spring MVC and Spring Framework runtime, how it flows. Um, so in the Spring Framework runtime, we have data integration. We have web routing, how the data access in the web and how the web integrate with the database and and uh, and how it integrate with the core container and the database. And in the middle, I think AOP and all that comes into the picture.
Okay.
And MVC flow is particularly for the web flow. I mean, so it is sorry, isn't this the same? So web MVC is, we are doing the same request and response from the JDBC.
Okay, let me add here. So we started by discussing about Spring modules, right? We said that Spring framework is modular. So what all modules are basically part of the Spring ecosystem is what we discussed, and these are the few of the modules, right? In data and integration access layer, you have a JDB, CORM and all, and then you have a web module which basically talks about MVC pattern model view controller, and then you have core container, right, which is the crux of the entire Spring framework, which forms the basis for dependency injection and IOC, right? And then you have AOP aspects, instrumentation, and then testing, right? Different aspects. Testing basically leverages JUnit and TestNG to write unit test cases. So all these are the important modules of Spring framework, and like every module, depending upon the use case and scenario we want to build into our application, we can make use of that respective module, right? And after that we went on discussing specifically about Spring MVC from interview point of view. What they would ask, right? They would ask you to explain MVC flow. So we talked about how when you are requesting for a certain web page, how the entire request and response chain follows, right? So that the request starts at uh, dispatcher servlet, or it is also called as front controller, which basically receives the request, and it finds appropriate controller, with the help of handler mapping and handler adapter, and the controller will actually the one who handles the request, and it delegates the request to the service layer, which then does some business logic. If at all need be, it would interact with the database, everything that happens at the service layer, and the service layer would return the model and view object to your dispatcher servlet. And your dispatcher servlet responsibility is to uh, return the model and view object to your view resolver and get the view out of it, right? And once a suitable view is found, it would add the model, and ultimately it will build the view with the data and your HTML content, right? Whatever the web page is, and that page would be returned back to the request. So basically the client browser. So the new web page is displayed there. So that's what MVC flow we discussed yesterday, right? And I told you in this particular diagram, the blue ones are the ones which are provided by Spring Source, and the one colored slightly pinkish purple, right? So they are done by the developers, built by developers, right? And that's what it is, right? So having said that, today we are going to talk about the rest of the basics of enterprise application, right? So let's see today what we have. Yeah. Today we are going to discuss about data formats. So typically in web, right? If or in web or in general, if two applications have to exchange data between them, they need to exchange data in a particular format, right? Suppose a system A or application A is talking to application B, right? So they both understand certain format in which data that system A is going to send to system B, and at the same time, when system B is acknowledging or responding to system B, in what format they'll send data, it's pretty important. So normally in software applications, most of the times they exchange data in the XML format or JSON format. If you see here XML format, this is just a small slide that will illustrate you how an XML document looks like? Like you have servers and like servers and one servers you can think of many, and under servers you have a server which is a child, right? Your servers is the parent tag and the server is the child tag, and under server you have a name, owner, created status, some properties of this server, right, which will be under server. So if at all we can add more server under this servers tag also, right, with these properties. So this is how an XML data uh, it looks like. And similarly, if you translate it to JSON, the same format, this is how it will look like, right? So JSON is a JavaScript object notation. It is another popular format in which the systems basically exchange data between them. Okay, so normally, like on day-to-day basis, we see quite a lot, right? If you're using internet, then to serve a customer certain thing, a lot of applications are interacting with each other, right? So let's talk about Amazon. You go to Amazon, you order something, you buy it, right? But when you go to the payment, the Amazon would have a payment gateway which would interact with your particular bank account, right? Suppose if you own an account with the US bank, for example, right? And your Amazon will interact with that particular bank, and it will check for the payment, and the bank will basically, it will request for the funds, and the bank will check if it will validate you the customer first, and it will check whether those funds are available with you, and once they are available, it kind of transfers the funds to the Amazon on your behalf, right? So that's what happens. So your Amazon is talking to your Amazon web application is talking to some banking web application, or it can be API also. So your Amazon needs to send some data to your bank about the name, your name, right, and all, and the money, how much you want to direct, and you would definitely enter some banking related information on the web page of Amazon website, right, on the payment gateway. So two systems are talking here, isn't it? So they should be exchanging data in some format, right? And that is what I'm talking about. Like your Amazon can probably use XML format to send data to the banks, or JSON format, depending upon the type of the systems they are, capabilities they have. Some systems they can consume XML, some systems they can consume JSON, or some systems they can consume both. It purely dependent on how the systems are built, right? And what kind of data exchange they're going to support it. So that's what it is. Okay, so this is a small representation of same data represented in different formats. And the last one is YAML, yet another markup language. So this one, it's basically, it is not used in terms of exchanging data between systems, but it would normally used as a configuration file for our applications, right? Like you have a Spring Boot microservice application, so you can configure all the properties, configuration values in a application.yaml file. Okay, so it's YAML file is mainly used for some sort of scripting and some sort of configuration. Okay, it's not a data format that is going to it will not serve as, it is not a data exchange format that will be exchanged between couple of systems. Only XML and JSON are, and YAML is something new that came into picture when microservices and cloud came into picture, right? So uh, YAML is usually considered as a cloud native configuration. Suppose you have some applications in cloud, so YAML would be the preferred way to put your properties, right? Configurations of your application. Specifically, it's not a data exchange format. Just mind that again. Only XML and JSON are your data exchange formats, right? Any questions here?
I think we're good.
Okay. So next we are going to talk about REST API. Okay, so what is REST API? I think it's a quite popular buzzword these days. Everyone says API or REST API quite a lot, right? Like, have you guys heard of it? Anyone? APIs, REST API.
Yes, we do the REST call and
What it is exactly? REST call. How it is different? What exactly? What's your understanding in general sense? By, I mean, what do you understand by APIs, or if at all you heard about REST API, like what was your understanding?
I mean, it's the same like we talked about yesterday, like we do the request, HTTP, we put the HTTP request for the JDBC database, and we have to, we use the put and call
Okay.
yeah, to request the data. I think we use put to print the data on the web page, something like that. I'm exactly not very clear, but it's like a request and response.
Okay.
Yeah.
So normally back in earlier days, I mean, even now, we have something called web services. Have you guys heard about this term, web services? So the idea of web services is to make systems that are interoperable to communicate with each other, right? So just take the example, previous example. I was talking about Amazon website, and then I was talking about your banking, right? Both needs to interact, right? So for that, you're assume that previously, right? Like before REST API was quite popular these days. REST API it is also called as RESTful Web Services. Okay, so what is, I'm just focusing on a term web service, right? So initially, I mean, back in days, we used to have a web services concept. Okay, even now it is there, it's quite popular. And these web services are broadly classified into two categories: SOAP web services, SOAP. Okay, simple object access protocol web services, SOAP web services, and then RESTful web services, RESTful, RESTful web services, right? So what exactly the idea behind this web services is, uh, take two applications that are there on internet, and they have to communicate with each other, and they are built on different technologies, right? And how they can interact with each other, right? How they can interoperate with each other, right? So that is what web services are. I mean, web services used to address these problems back in initial days. Like, say for example, if you take another example, right? I mean, say for example, you have an application that is built on Java, and you have another application that is built on Python language, right? Now they both need to interact with each other, right? Assume your Python is built in your Amazon is built in Python language, and the bank application is built in Java programming language, and they both need to interact with each other. How they would interact, right? We spoke they would exchange data in XML and JSON format, right? But in what mode they will interact, right? So they both are interoperable, isn't it? So I mean, because they are built on different technologies, it's not like both the if they are built on Java, both the applications, right? Java has something called as socket programming or web socket programming. Okay, if the both are built on Java, they can use that to interact with each other. But here they're built on a different languages. One is Java and one is Python. Python is not having that WebSocket programming. So how do they interact with each other? This is the question, right? So for that, to address that, you have this web service in place. So which are broadly classified into SOAP and RESTful web services. And they both make use of HTTP protocol uh, underlying. So the web HTTP protocol to interact with each other. Like your Java application will use HTTP protocol to send request to your Python application, and your Python, this HTTP protocol is something independent of the platform, isn't it? It's just a web protocol. So every language would definitely have support for HTTP, isn't it? It's a uh, universal protocol. Like almost every programming language out there is compatible with HTTP, isn't it? So basically the web protocol, isn't it? So like SOAP web services, they are basically a stateful web services where you can exchange the state of your particular client or a server to the other system, right? And when they interact with each other, this state would be active. There is some state-based communication that is going to happen, right? What exactly state-based communication is? Like whenever you send a request now, okay, and the next time also you send another request, the receiving party should be able to relate the second request with the previous request, right? So that is called state. Okay, stateful web services. So there would be some context that will be common across all requests. So that way the receiver would identify these all requests belongs to this particular interaction only. So that kind of state management would be there. Your SOAP web services are sort of uh, the stateful web services, and their interaction was purely in format of XML. So the both systems, right? Your Java application and the Python application both would exchange data in an XML format. So SOAP web services, they used to support data exchange in XML format, and you need to, and there are a lot of things there, right? Like the first one is you need to agree to a predefined schema structure of the XML. Like both your Python application and Java application, they should understand to a certain format of XML. Like the Java application will tell this is the format in which I'm going to send you data every time, and they to the Python application, and they both get into an agreement. That means your Java application cannot modify XML just like that and expect Python application to able to process that data successfully, right? It can't expect that. It has a well-defined schema, I would say. Schema is, it's like a contract agreement in what format XML would come, what all data it would contain and all. It's a pretty much agreed upfront, right? So those kind of things are there in terms of SOAP web services. And then you have RESTful web services, which is completely stateless. That means like you can the receiver can process multiple requests, right? No need to correlate with the previous request. So that kind of helps helps for more decoupling and promotes more asynchronous communication between the systems. And definitely and most of the RESTful web services, they can consume data in both XML and JSON as well, right? JSON format is quite popular for your RESTful web services. So when you exchange JSON typically, right, you definitely no need to agree any particular format upfront, right? Like, I mean, you send it, but it's not mandatory. Like, the more you send, the API should be able to accommodate and all, right? So it's completely a stateless web service. So this is how the web services are broadly classified into SOAP web services, simple object access protocol, and the RESTful web services, right? And when coming to REST API, this is nothing but a RESTful web services, right? So if I expand the abbreviation, REST stands for Representational State Transfer API, Application Programming Interface. Okay. So let's read out the definition, then we'll understand a bit more, right? So the REST API, also known as RESTful API, is an application programming interface API or web API that conforms to the constraints of REST architectural style and allows for interaction with RESTful web services. REST stands for Representation State Transfer and was created by computer scientist Roy Fielding. So basically, if you understand the term, understand the catch here, REST is an architecture style. Your SOAP is a protocol, okay? Simple Object Access Protocol is a protocol, whereas REST is a architectural style. So REST is purely a theory in terms of a guideline in terms of how systems should interact with each other, right? So REST is an architectural style. So basically, let's take a couple of examples of REST API, where and how. Sorry for that. Yeah, where and how we are basically seeing this REST API in use, right? So I think if anyone using Quora, for example, Quora, have anyone ever used Quora?
Yes, I think it's like the information, like you can search anything.
Yeah,
Yeah.
you have some questions and some people would be
Yeah.
answering there, right? So not just Quora, I think you might have definitely come across some website, like say Facebook, okay, or else some other website, right? Where, let's take Facebook only. Previously, or Quora for that matter. Previously, when you want to interact with them, you need to register with them, right? And you need to create an account with them, be it Quora or Facebook. Now, if you want to create an account with Quora or Facebook, you need not necessarily log in with, create an account with them. If you have Google account, right? Quora says you can either create account with me, or if you have Google account, you can sign in with Google account to onto our application, right? Similarly, Facebook, if you have Facebook, if you want to sign with us, that's fine. Or else, if you have already have Google account, you can make use of your Gmail Google account to sign into our application, isn't it? Like, you might have seen this, right? On the sign in options, it would show as Google. Remember? Does it sound familiar?
Yes, yes. So most of the application are like right now integrated with other
So
application. I think so.
right. So basically, the identity management is given to the identity management solution is leveraged from some other applications, right? Rather than these systems maintaining their own identity management. Like I'll just give you an example of product. Let's just see that. I'll just show you here some of them who isn't familiar, right? Like, okay, I already logged in here. I'll just open this. Okay. Now, if you see here, you have three options here. If you have account, you can log in, but if you don't have, you have three options here. One is you can continue with Google account, you can continue with Facebook, or you can sign up with email. That means you can create your own account with Quora.com itself.
You're, I think you're still on the PowerPoint page. We are not able to see.
Oh, okay, okay. Is it visible now?
Yes.
So I open Quora.com, and here, if you could see, you have a Google.com. So you have Facebook. That means if you have accounts with Google or Facebook, you can use same account to create an account with us. You no need to create another account with us, right? So this is one example, right? And the moment I go to Google, continue with Google, if I say, right, this will redirect me to the Google page. So here I can select a particular Google account, and then I can from there I can what will happen is Google will validate my username and password which I enter, and it will send to Quora that whether I am a verified or valid user or not, right? And Quora will take that as response. If it is a valid, if I am a valid user, it will let me through and I can use Quora. Okay. If I am not a valid user, Quora will not let me to use it at all. So Google will tell whether I am a valid user or not. Okay, so that means the identity management is being transferred, is another application. Google is basically taking care of. Quora is a different application, right? But Google, and at the same time, Facebook also providing this kind of solution, right? Facebook Facebook knows more details about a person than Google, isn't it? Like you update. So Facebook can also started providing this service. Like if you want, we can validate some people for you, whether they're valid people or not, and we will tell you. Then you can let them use your system, right? So this is that kind of functionality. So in the back end, Quora and Google, or Quora and Facebook, they use REST APIs to interact with each other, right? So in the backend, your REST API also uses a HTTP protocol, and they exchange data in a JSON format, right? Like if you control shift, if I press this, you can see the network tab here. Okay. So if I click on this Google, you can see, right, some HTTP requested from Quora. Okay. And in the response, it hasn't anything, but it made some HTTP request. Okay. And as a response, you got this, like say this page, right? Now let me just click on something and see what happens in the backend. Okay. I selected one Google account and I'm logging in with that account. Okay, I can forward this password. Okay, so I forgot this password, man. But anyway, when you log in it, Google will send some update to Quora. Okay, this is a HTTP call. Okay, some HTTP request, Google will send it back to, this is a REST API. Okay, so basically the REST API, they make use of the URLs. This is called URA, Uniform Resource Locator or Uniform Resource Information. They make use of URA to interact with each other. Okay, so the URA typically contains some domain name and some path of where that resource is, right? So that's what it is. Okay, so they can basically make a HTTP request to a REST server, and it will return the HTTP response. And not just browser, the other applications can also make use of the REST API. So in general, what is API, application programming interfaces? It is nothing but you can think string class as an API in Java. It's a pre-built for us, right? To work with strings in Java, we have string API. You can say you have a string API. It's just that, it provides a lot of methods to work with string, isn't it? To reverse a string, string has a string reverse method. To know the length of the string, you have length method. Are you implementing this? No, right? Java has already implemented these functionalities and they gave it to you to calculate length, isn't it? So this, you can consider string as an API. So similarly, depending upon the functionality, you can create your own API, REST API, right? So like I said, it supports HTTP communication, and all the HTTP requests that your browser sends, right, or other application sends. We in generally, you have uh, 5 different, I think, yeah, 5 different HTTP request methods. The first one is get request, post request, put request, uh, and what else we have? Get request, post request, put request, patch request, delete request, and all, right? Like for example, if your browser want to, or let's check the browser here, if it wants to get some information, the REST server to the other application, it will make a get server. Get server will just simply
Yeah.
fetch some yeah.
Again, we are not able to see your screen.
I'm just sharing you the slide. Is the slide
Oh,
not?
okay, okay.
I'm not. Yeah.
I thought yours. Okay.
No. Just slide. So probably I'll show you here. I think this slide was good. Yeah, just look at this slide. Yeah, if you see here, you have a get request. So you're just simply getting some books list slash books. Okay, it will get the all books in the database. It is like if you want to retrieve the information, you make get request. And if you want to delete a book, you say you also pass specific book ID. It will create a book, right? And you have then post request, which is, that means you are creating a book at the backend. Post request is like, suppose you are signing up Quora, right? You are signing up into Quora. So you will provide your first name, last name, email ID, phone number, location, state, zip code, and all, right? So all these details will be sent. It will be taken by you as a user sign up, user login or sign up form. You will take all this data and you would enter, you would transfer it to the backend system. You would then store the data, and it would generate some password for you, or you may ask to choose your own password, sort of, right? And all this data, like sign up forms. So this kind of data is a post. Post is like from the client to the server, you are trying to create something, some resource at the server level. And then you have put. Put is like you have to modify some information. Like suppose you are updating your profile information, you are updating your email ID, or you are updating your state, right? Normally, once you create an account, you have a profile where you can go and update some information, right? So put basically is like update. Okay, so these are the different types of requests, like get, put, post, delete. In HTTP, you can make any type of these requests. Okay, and your HTTP accordingly it will return a response to you, right? And when typically HTTP returns a response for your request, it will also return something called response code. Okay, by looking at the response code, you can understand whether the request that you made, be it a get request or put request or post request or delete request, whatever you make, it is successful or not. You can understand that by looking at the response code. And broadly, your response codes are classified into 4 categories. Some response code starts with 1, some response codes start with 2, some response code starts with 3, some with 4, and some with 5. So your HTTP response codes are broadly classified into these 5 categories. Okay, I'll just show you that as well. Response ports. Okay. Yeah, we'll take this slide and then we'll come back to the other slide. So if you see, this is how your response ports are classified: 1x, 2x, 3x, 4x, 5x. 1x in the sense it will start with 100, 101, 102, 103, and so on. 201, 202, 200, 201, 202, 300, 301, 302, 400, 401, 402, 500, 501, 502. Likewise. Okay. This is how for every get request or put request you send, right? This is how your HTTP codes would react. Okay, we'll just take this. This seems to be some good slide. I hope you guys are following what I was saying, right? Or any confusion here? Are you guys able to follow?
Yes.
Yeah.
Okay, this is not visible, right? It has a lot of good information. Okay.
It's too small for me.
Okay, let's take this. This is simple. So we'll just keep at this. So like I was saying, your response codes are broadly divided into these categories, right? And every category has certain significance. If you make a request and you got a response code as 100, for example, it gives you some informational from the server, return you some informational update. And if it's 200 related code that you receive, that means whatever request you make, it has been successfully processed by the server and you will get a proper response, right? So 200 is like success. Your request is accepted at the other end and it was able to give you some response also. Along with the response code, it will give you some response, right? Some JSON response. And if it is 300, it is like redirection. Like from this side, you are jumping to other side, right? You click on something and it will take you to other website, right? That's a redirection. And 400 is like client error. Client error in the sense, suppose you are making a get request, right? Or put request. Let's take suppose let's take this scenario itself, right? Amazon is trying to contact your bank to take the payment. Amazon will make a post request because it needs to send all your data, right? Like the credit card number or the credit card expiry date, the CVV, the name of the credit card. It needs to send all this information to the bank server, right? So your Amazon will send the post request with all this information. Suppose that credit card you are using is invalid, or for example, the credit card might have been expired already, or CVV name is incorrect. If there is some problem in the input Amazon has passed to the bank, like you might have entered something mistakenly, you might have entered wrong CVV code or something, right? So if that is the case, what is going to happen, right? Your bank server will say, boss, this credit card number is invalid, or this CV expiry date is, the card is already expired. So it would throw some error and it would return a 400 error code saying, then the client, the client who sent me the request, this is a problem at their end, right? So that means that there is an invalid information that I got it, so I cannot do anything about this, is what 400 error says. On the other hand, 500 error, they talk about server errors. Like for example, in the same scenario, Amazon is passing all the data accurately. Bank also understands that data, but there was some technical issue at the bank end and it was not able to serve that request. Then it will give you 500 error, right? Like, so all in all, you have these three important codes. One are 200, another is 400, and next is a 500. These are pretty important response codes, right? Because 200 response codes will indicate that your request is successful and you will get some response, right? If it is a 400 code and 500, you will not get any response, but it will help you to understand the problem. Like 400 will tell the input itself is wrong to the server from client. and the 500 ports will tell the server itself had some problem. Even the client is fine at their end, but the problem is with the server, right? So this is what your HTTP codes are, right? So if you see in 200 success is called okay, in 300 301 302 304 there are different error codes, right? Like and then in 400 you have these kind of error codes: 401 403 404 405. Unauthorized is something like you're trying to do something on the server but you don't have permissions to do it, sort of, right? And if your credentials are wrong, you will be forbidden to use something. So this is 400 error and all. And 404 is like, you might have seen, right? You will get HTTP 404 error in web pages when you're navigating some, you will definitely come across. So 404 is like you are requesting for some resource which is not present at the server. Okay, not found, something like that. And it's typically 500 errors. 500 errors if you see, like not implemented, bad gateway, service unavailable, gateway timeout, or if there is some exception at the backend, like some null pointer exception or some arithmetic exception, right? In that cases, your some runtime exception, if you get, your server will send 501 error, or probably 503, right? That's all. That's all with respect to HTTP status codes, guys. So when it comes to REST API, you need to understand that it's just an API which your client, your requester is requesting through HTTP protocol using one of the HTTP methods. Like it can be get request, put request, post, or delete, and your server would return that information, right? With the appropriate HTTP response code. Yeah. Any queries here, guys? Any queries here? And it's a lot of theory, but it's important that you guys understand REST API, because in the last, we are going to build a microservice, right? An API using Spring Boot. So that will give you a better clarity. Okay, so there we will be defining put request, post request, and we would also send appropriate response code and all. You will definitely, you're going to see that in action with the proper hands-on. Any queries, like what is REST API and how it works and all, right? Any queries here, guys, or shall we move on?
We can move on, like if we can show us like how get put and all that, those request work.
Yeah. Like I said, in the end, we have a Spring Boot demo, right? There we are going to build a REST API. So using Spring Boot, and microservices are nothing but REST APIs. Okay. So we will do an end-to-end functionality in the last session. But for now, just understand the theory part. Okay. Like 2 more sessions, we have theory. And yeah, probably not 2 more sessions. I think 1 more session we will be done with theory, and the next session we will cover the hands-on. We'll do, I told you, right? We are going to build one Spring Boot application end-to-end. So we will do that. Then you will understand this better. Okay. But the theory part you guys understood, right? Or any confusion around in there? That. Yes or no, guys? Can I move on?
Yes.
Yes, sir.
Then now we are going to talk about packaging applications, right? So what is packaging an application, right? So in general, if you take, right, I think you know, right, your Java class basically compiles into a class file, right? .java, when you normally write programs in .java, and it would compile in form of .class, right? And normally if you take any Java application, some application built in Java programming language, how many Java classes do you think it will contain?
Many,
Like thousands, right?
there will be, yeah.
It can contain thousands of Java classes to support the functionality of that application, right? Now the question here is, how do you package those 1,000 classes and how do you transfer or how do you share, right? That's a question. How do you share in the sense, how do you deploy them? It's like, do you guys know what are data centers?
I mean, not exactly.
Okay.
I
Now,
know, but we know, but don't know, like,
okay. So
just heard about the terms.
okay. Let's take this example, right? For that, I'll just take example of Amazon, but you can correlate it to any web application. So the moment type Amazon.in, for me, I'm based out of India, right? So the moment I type Amazon.in in the web browser, I am seeing this web page. What is really happening in the backend?
It's getting the data from the database.
Where exactly? Where is the database?
In Oracle or any of the data center. Yeah, data center. Yeah.
Data center, right? So basically, internet is like a world that is connected through wires, as simple as that, and through satellite signals. Okay. So normally in the backend, what happens when I type Amazon.in here, right? It would ultimately try to find an IP. Okay. You're following me, right? Like if I go to my terminal, CMD. If I do ping, you guys know IP address, right? What is IP address and all?
Yes.
If you see it, if you ping Amazon.in, ultimately there is this server. The IP of that server is 13.35.215.244. So this is the server that is sending this web page and this data to me. That server is sending this web page and also this data, whatever you're seeing here. Understood, right?
Yeah.
So normally, if I type Amazon.com, right? This is the website I'm getting. So if you see this particular data is indirectly being like I will say type Amazon.com. Okay. If you see Amazon.com is given by some other IP, not the same server. Some other IP is giving me this website. So what exactly how this works, right? So typically what Amazon will do, it will build something called data center. Data center is nothing but it will just some land, it will construct a building there and it will put all the servers there. Server means, what is a server? What is a server, guys?
It's like it provides a service to.
Does anyone uses desktop?
Yes.
Who is using? You are using Varsha desktop.
Yeah.
So what are all the your desktop comprises of?
CPU,
Motherboard,
so,
CPU, monitor, and keyboard, right?
yeah.
When I say server, it is just simply CPU. Okay. You got my point, right?
Yeah. Yes.
When I say server, it is nothing but your CPU. So what your CPU contains, it will contains some motherboard on top of and some hard disk space. It will contain some RAM, some CPU and all, right? So that is the heart of your monitor, is just a display of what your CPU is doing, isn't it?
Yes.
So what Amazon does is it uploads its web application in a CPU, in a server, right? And that server is connected to the internet. Okay. So and it will create a DNS name, like, which is called a domain name server. So it's like a global phone book. There it will make an entry that when you type amazon.com, amazon.in, contact to this particular IP is what it will make that registry, and that registry is available to the all internet service providers across the world. Okay, so I am using some broadband connection here, right? So that when I make amazon.in or amazon.com, that broadband internet service provider will interact with that registry and will find what is the IP of this particular website, amazon.com, and accordingly they will find the IP. This is all happen in the back end, right? They'll find the IP and they will come to this IP and they will request the web page information, right? That server will give you this page with the data. Okay, that is what happening in the back end. So when you say data center, okay, it is just a building. It will look like this. Okay. I'll just show you. My system is got stuck, guys. Just a minute.
So when we are pinging the IP address, server is getting the data from the data center and sending it back to the.
Yeah. So if you see here, when I ping this particular amazon.in, this amazon.in internally, the DNS registry, the ISP, everyone resolved the name IPS 13.35.215. Okay, so if you see pinging 32 bytes of data, so it is sending some data, and I am getting the response from reply from, you can see, right? I'm getting the response, and it will tell how much time it took. It took 8 microseconds, 4 microseconds, 113. It received it sent 4. If you see here, it sent 4 packets of data and received 4. So you understood, right? So that means in 4 microseconds, an average 35 microseconds, I'm getting response from this server. Okay, so ping will check that. Okay, now coming back to data center, I think if you could see the diagram on this right, you can see the diagrams on the right, the small diagrams.
Yeah.
So if you see, it will look like a bookshelf. In data center, it will look like a bookshelf. But instead of books in every shelf, you will see server, one CPU. Understood, right?
Yeah.
That is what data center is. Your data center will contain hundreds of CPUs. So each CPU will contain some processor, some memory, some storage, some disk space and all. And all these CPUs are using LAN cable. They will be connected to the internet. So anyone across the world, the moment it are connected to the internet, anyone across the world can access that, isn't it? So ideally this amazonweb.com or amazon.com or amazon.in server might be is located in US, but I'm able to access it through internet because the data center is where these files are stored. Amazon.in or amazon.com files are stored is connected to the internet through data center, right? Yeah, you have a question, Varsha, go on.
So this is for the internet-based application, which is Amazon. So if we are working in real time, that will be a enterprise level application, right? So
yes,
it will follow the same.
anything you put on internet, it will be through data center, right? But some applications, they will be intranet based applications. That means they will also have data center, but they are not connected to the public internet. Okay.
Right.
Like you have a private network. You can create your own private internet network, but you don't, it will not be available to complete end-to-end users worldwide. Like Amazon, do you think Amazon maintains just Amazon.com one application? Amazon will have hundreds of applications, but the one it exposes to the world is Amazon.com. But there are a lot of websites it internally uses to do, like you click on Amazon, but internally it uses a lot of softwares to create inventory, update inventory, consolidate all the payments that it receives. It uses a lot of other softwares. You're understanding, right? And those softwares are internal to Amazon. We are not interested in those softwares, isn't it?
Yeah, so once it's a web-based application, internet-based application, then it's gonna follow the same, like it's gonna go to the data center and get the HTTP request from there, right?
Right. See, even internally used application, we call internet and intranet. Okay, I'm just typing those words here. Okay, my screen got stuck, guys. Intranet. Okay, let me just type in the chart here. Okay, internet and intranet. Okay. The N is missing here. Internet is something that is connected to the public world. Everyone can access it. Okay, you're understanding, right? Intranet is something only a certain set of people, like companies, create their own private intranets. It's like a private network. Okay, this is like a public network. Okay, this is a private network. Private. Okay, so both internet and intranet applications, they sit on data center only, but they will have a different networking capabilities which enable them to open to public and keep them private. Okay, so Amazon will create a private network, and this private network will be available only for Amazon employees, not everyone. So when you log into when you open some application of their intranet network, it will Amazon will give users some email ID like varsha@amazon.com, something of that sort, and using them, they will validate and they can log into the Amazon intranet and they can access the internal applications. But when you internet, you don't need any account as such, isn't it? Like it's open to public. You can see Amazon.com. You no need to have special permission to see Amazon.com, isn't it? You got my point? So that's what internet and intranet applications are there, but both they sit on data centrally. But how they differ, they will have a different networking capabilities. So that way, some information is private, some information is not private. Okay. Now, the data centers are nothing but just building like this. So in this kind of building, you will have hundreds and thousands of servers. Okay, CPUs, right? So data centers buildings, they use a lot of water, a lot of cooling equipment they need. Okay, because they generate a lot of heat, right? I think you guys, if you use your laptop continuously for 1 hour, 1.5 hours, and or else if you use your CPU, you would see a lot of heat, right? Heat getting generated. So and assume you have thousands of servers and they are running non-stop. These servers, they don't run for 1 hour, right? If do you anytime see your Amazon.com down for 1 minute?
No.
If it is down for 1 minute, how much business they will lose? They will lose so many orders, right? So much money they will lose, isn't it? So these servers, they run 24/7 so that the Amazon.com web application is available to you. You got my point?
Yeah.
See, the same application, they can't put it in a single server. The Amazon.com website, they might deploy parts of it in multiple, like thousands of servers, because like suppose a server maximum capacity is, let's assume 64 core CPU and 256 GB RAM. Okay, servers will typically contain that much heavy configuration. Normal end-to-end users like us, we just use 2-core CPU, 4-core at max. We'll go till 8-core. 8-core is also very rare for us, users like us. We will at max use dual core, 2 cores only. But memory wise, we will at max go till 16 GB RAM, right? 8 GB is like really huge for us. But if you use some intensive applications like machine learning, if you build some programming around that, or Photoshop based applications, then we will use some 16 GB, something of that sort, right? But your servers, their hardware is completely different. They are like, if you run your computer 24/7 for 1 week, you will definitely, your desktop, your computer will be definitely, go into repair. It will face some kind of problem, because the hardware is not able to sustain that kind of heat and that kind of usage of that kind of prolonged periods continuously. You got my point, right? Whereas your server hardware, it is built specifically to sustain that heat and run for longer durations without impacting the performance. And every server will contain very high-end configurations, right? High-end specifications. So like Amazon.com per day, it is accessed by billions of users or millions of users, right? Like, to support those millions of users, you will create so many servers, right? See, end of the day, Amazon.com has to put their application in each of their server, right? Let's assume Amazon.com is developed in Java. So that means Amazon.com is composed of 10,000 Java classes. So it need to put all these 10,000 Java classes in each and every application, all these 1,000 servers, right? Which will support millions of users across the globe. Yes or no?
Yeah.
So how efficiently can it ship these 1,000 classes to all the 1,000 servers, right? So now let's take one general scenario, right? Like, just a common sense question. You want to transfer some 100 files from your laptop to your hard disk or USB. What you would do? What you would do? Have you done that anytime? Transferring some files from your hard disk to your computer or USB?
Yeah.
So what do you do?
Just transfer to USB.
But yeah, you just transfer it. But if you want that to happen quick, what you would do? Suppose you
I
have
know I've done that in previously, but forgot. Like, there is one app we use. Not
WinRAR,
app, but
WinZip.
yeah, not WinZip. Like,
But the idea is to compress, right? I mean, you
right.
use some softwares which will transfer faster, that I understand. But
Yeah.
if you want it technically, they will also compress these files for you. So the idea is, you would zip this content, right? You would zip it, you would compress that, you will see, instead of transferring file by file, if you compress all these files into a single zip folder, transferring that zip is easy for the computer rather than transferring file by file. Because transferring file by file, after transfer, it need to check certain things, right? But if it is transferring single file, then it can avoid checking these things for each and every file. So if you compress, then it would easy to transfer to your hard disk or USB, isn't it? You got the point?
Yes.
So similarly, Amazon.com, to transfer it to 10,000 Java files to each and every server, it would compress them and it would transfer to all the 1,000 servers. You got my point now, right? And this compression is called jar format. This is what packaging application means. Okay, you have an example.java. When you compile it, you get example.class, and you package it and you compress it. So you compress it. So that is nothing but a .jar file. It is called Java archive. So similarly, in software applications, you have these three formats: jar, var, er. Java archive, web archive, enterprise archive. It is nothing but a compressed form. So each of these form contains thousands of classes. So they are a single file, which will be easy to ship your application across any location or any server. Understood, right? That's the idea behind this. So we will look into this jar, var, er in detail tomorrow, what exactly they contain and what sort of packaging they will contain and all. But this is what packaging applications is. I hope you understood the core idea of this, right?
Yeah.
Okay, these are like compressed formats. Like you combine all your 10,000 Java files into a single compressed file called jar. Okay. Any queries here? Or else we'll stop for today. Okay, we'll continue our discussion for tomorrow.